So the purpose of this video is to take a look at some basic definitions of statistics and how they're used in various capacities in describing data sets and statistical analysis. So let's take a look at some of the basic statistics definitions. And statistics is the art of decision making based upon data in the face of uncertainty. Data is used a lot to try to make decisions and be smart with the information that you're given, and that's the basic gist of statistics. The difference between population, sample, and a statistic, let's take a look at that. A population refers to an entire group of objects being studied, and what I have here is a funnel, and at the top of the funnel is where the population would go. It's the widest group of data. We're going to narrow that funnel down, and we're going to narrow the scope down of a statistical study by picking out a sample, and that's a subset of the population. And the actual statistic refers to some trait or some characteristic of the sample. We're going to go through some examples here in a minute and talk about these concepts of population, sample, and statistic, but they're sort of a general gist of how this looks visually in a funnel and how it looks verbally in the definition. The difference between a parameter and a statistic: a parameter is the measure of an entire population, and a statistic is used again to measure some subset of a population. We'll take a look at an example of this in a second. And then there's two main types of data: categorical and numerical. And numerical data is data that's measured and can be numbered, like a time, a distance, a temperature, something that has an actual numerical value. And categorical data is data that is placed in groups, such as political affiliations, Democrats, Republicans, Independents, grades, A, B, C, Ds, and Fs, anything that can be put into groups. So there is the difference between numerical and categorical data. Now, as promised, I said we were going to take a look at some examples of using these definitions specifically with some examples. So here we go for the first one. We have 27 SUVs that were randomly selected from a Ford plant in Detroit, and 21% were found to have defective airbags. So let's take a look at the population. Here I am at the top of my funnel. The population is the group of objects that are being studied. In this case, it's the SUVs in a Ford plant in Detroit. So it is a big group of objects. We narrowed it down to our sample as we're working our way down the funnel to 27 SUVs, and at the very bottom, at the end of the funnel, 21%, the statistic of those 27 SUVs had some sort of defective airbags. Let's take a look at another one of these: population, sample, and statistic. Study of Math 114 students was taken at the end of spring semester 2012. A sample of 30 found 78% had a positive experience with the course. Here we go with the population and this funnel concept. The population were all Math 114 students in the spring of 2012. The sample, 30, not all, but just 30 of the 114 students. And the statistics: 78% of the 30 Math 114 students had a positive experience with the course. So we said something very specific at the end: 78% had a positive experience. Let's compare parameter with a statistic. 90% of RU students own a cell phone. That is a statistic. It is not 100%. It is not all Radford students own a cell phone. The yearly payroll of all of the players on the Washington Capitals is $21 million. That is a parameter because we're looking at every single player, the entire group of players for the Washington Capitals. If I would have said 40% of the salary cap goes to the goaltenders, that would be a statistic, but we're looking at all of the players and their payroll. 82% of adults surveyed admit to drug use. That is a statistic. that is not 100% of the adults, but 82% would be a statistic. Now, comparing categorical and numerical data. The times of the women's 200-meter run from the London Olympics, that would be numerical. We have the fastest, the slowest, we could find the average, the most frequent time, anything that's measured with numbers is numerical. The eye colors of student in a class, that would be categorical. Dark eyes, blue eyes, green eyes, hazel eyes, we put people in a category. We cannot find the average eye color. We have to put it in a category. And the social security numbers of students in a class, that is categorical because it breaks down numbers based upon the area and part of the country you were born in. So that puts you in a category.